If a highly advanced civilization had once dominated the Earth, would there be any evidence left for us to discover? Geology alone offers no easy answers. Stones crumble, coastlines shift, and rising seas swallow entire landscapes. Time is not a guardian of memory. Instead, it acts as an eraser, relentless in its consumption rather than preservation. But what if we aren't the first beings to gaze up at the stars and wonder about our place in the cosmos? What if others asked these same questions long before our cities rose, before our satellites circled the globe, even before the continents settled into their present forms? Could another intelligence have emerged, thrived, and disappeared, leaving behind cryptic clues from unusual isotopes to extinction-level enigmas, from geological anomalies to myths passed down through generations? This is the haunting question that science dares to explore, though it may never fully answer it. This concept is known as the Sorian hypothesis. If it holds any truth, it means we are not the first beginning, but just one chapter in Earth's vast, ancient story. Our planet has existed for billions of years, but not in a way we easily comprehend. It's not simply old, like a weathered stone or a forgotten ruin. It is unimaginably ancient, a world that has burned, frozen, submerged, fractured, blossomed, and perished repeatedly. 4.5 billion years of chaotic spiraling time have sculpted this planet, creating epochs so alien and harsh that even their silence seems to conceal secrets. A world that has buried its past far deeper than our tools or curiosity can reach. Many people tend to think of time in terms of centuries or maybe millennia when feeling philosophical. But what happens when we stretch our imagination across millions or even hundreds of millions of years? What stories might be locked away in the layers of ancient rock? What civilizations could have flourished and crumbled long before the first human ancestor drew breath? This isn't mere fantasy. It's a question grounded in evidence and a challenge to expand the limits of what we consider possible. Surprisingly, it might be far more plausible than many have dared to consider. The Sorian hypothesis, coined in 2018 by Gavin Schmidt, director of NASA's Goddard Institute for Space Studies, and astrophysicist Adam Frank, asks a straightforward yet unsettling question. If a technological civilization had existed on Earth millions of years ago, would we be able to detect any trace of it today? Their answer reveals a profound blind spot in our understanding. Earth is not a static museum preserving every detail. It is a dynamic graveyard, continuously reshaping and renewing itself. Continents drift, oceans rise and fall, volcanoes erupt, and entire mountain ranges are ground to dust and swallowed by seas. Soil layers are repeatedly overwritten, erasing all but the most persistent traces. Even the dinosaurs, the species that dominated the planet for 165 million years, left behind only a fraction of their former presence in the fossil record. Fossils are but a tiny sliver of the vast array of life that once thrived. Now imagine a civilization lasting only a few 100,000 years, a mere blink in geological time. What remains would persist after 10 million or even 50 million years. Would we recognize any evidence of such a society, or would it dissolve into the deep silence that covers epochs like the early Triassic, Devonian, or Carboniferous? Understanding what might have existed demands we confront how much of Earth's history has already been lost, and how fragile the notion of permanence really is. Take the Sahara Desert, for instance. It was a lush green savanna filled with rivers and abundant wildlife only about 6,000 years ago. Today, it is an arid wasteland of sand stretching thousands of kilometers. Any settlements from that so-called African humid period have long been swallowed by shifting sands and climate change. Now magnify this process over hundreds of millions of years. Volcanic eruptions can obliterate entire landscapes in moments. Lost continents like Zandia or Doggerland have vanished beneath the seas, forgotten by time. Glaciers grind down entire civilizations to dust. Plate tectonics does more than rearrange continents. It recycles Earth's crust. The ground beneath your feet might once have been ocean floor, melted and remade deep inside the planet's molten core. Civilizations, as we understand them, are incredibly recent phenomena. The oldest known city, Jericho, is about 11,000 years old. The Great Pyramids, only 4,500 years old. If the entire history of Homo sapiens were compressed into a 24-hour clock, our earliest written records would appear only in the final seconds before midnight. We are fleeting, and what we create lasts even less. Given enough time, Earth erases almost all traces of human activity. In 1970, Stanley Weinbaum wrote a short story called The Lotus Eaters, where explorers on Venus find a sentient plant species that leaves no cities or artifacts, only stories encoded in genetic memory. Though fictional, it speaks to Earth. Intelligence might not leave behind the kinds of footprints we expect. When we think of civilization, we imagine steel and glass, skyscrapers, satellites, power grids. But that's a projection of ourselves, a carbon copy of our path, fixed in concrete and silicon. What if intelligence took a different path, leaving behind no megastructures, no machines recognizable to us? This uncomfortable idea forms the core of the Sorian hypothesis, playfully named after the reptilian beings from Doctor Who lore said to have ruled Earth before humans. This concept isn't conspiracy, but a serious intellectual exercise in planetary science. Schmidt and Frank's influential paper concluded that detecting an ancient industrial civilization in the geological record might be possible, but only if we know precisely what to look for and are fortunate enough to find it. Picture a civilization emerging 250 million years ago during the Permian. It advances rapidly over a few 100,000 years, harnessing energy, shaping its environment, dominating ecosystems. Then, climate shifts or biosphere collapse occurs, or maybe they vanish quietly, victims of their own progress. Today we might find no bones, no ruins, only a sudden spike in carbon isotopes, an unusual sediment layer, gaps in biodiversity, or minerals fused in unnatural patterns. These could be the ghosts of vanished industry. This is geology's reality, relentless and unforgiving. For example, trinitite, a glassy substance formed when the first nuclear bomb fused desert sand at the Trinity test site, might confuse future archaeologists millions of years from now. Would they recognize it as an artifact or dismiss it as volcanic glass? Time doesn't merely erase, it camouflages. Compression, heat and pressure erase detail. Fossils seldom form. Organic materials decay, metals corrode, plastics degrade. Even our civilization's traces may vanish within 10 million years. Roads crumble, skyscrapers collapse, satellites burn up or crash. Microchips dissolve. Monuments we designed to last centuries mean nothing in the face of deep time. The Great Wall of China will become dust. Mount Rushmore eroded to faceless stone. What might remain? Perhaps plastics buried in ocean sediments, chemical anomalies, or radioactive signatures from nuclear tests. But without context, even these clues would be difficult to link conclusively to technology. Imagine a civilization that used primarily organic, biodegradable materials, plant-based polymers, composites, living structures grown rather than built, tools dissolving with time and water. How would that appear in the geological record? Could we even detect it? Perhaps we are already surrounded by its traces, unrecognized as artificial. This is why the Sorian hypothesis is vital. It pushes us to ask better questions, to broaden our search criteria, and to accept that intelligent life may not follow our familiar path. Our bias toward technology like ours might blind us to an alien history inscribed deep within Earth's bones. Schmidt and Frank are not alone. For decades, thinkers like Carl Sagan pondered whether civilizations could rise and fall repeatedly on habitable worlds, leaving only subtle thermodynamic imprints. Arthur C. Clarke imagined deep-time memories encoded in biology. Speculative biologists and artists have envisioned what intelligent dinosaurs or aquatic species might have become if evolution had taken different turns. This isn't about lizard men. It's about humility. realizing that 99.999% of Earth's history unfolded without us, and we may be no more permanent than trilobites, mammoths, or ammonites. We walk a narrow ridge above a vast chasm of forgetting. A strong wind, a solar flare, a supervolcano, a pandemic, or a war could end us. And when we fall, Earth remains, patient and indifferent, ready to erase our traces as it always has. Stone remembers none of our pride, but buried within it perhaps is a secret, a fragment, an echo, not of gods or aliens, but of something like us, something that walked, wondered, and vanished. Try to imagine a map, not of nations or continents, but of time. A map stretching from today not back thousands of years, but hundreds of millions, each inch representing millions of years. The age of dinosaurs far off to the left, the Cambrian explosion barely visible at the fringe, and us, a microscopic pinprick at the extreme right edge, a fleeting flash, a whisper in this vast timeline. Everything we know, from agriculture's dawn to Voyager's launch, is little more than the fading afterglow of a match burned out in the dark. Geologists call this deep time, not just old, but inconceivably vast, a chronology so immense it erodes the very idea of history itself. In this endless expanse, Earth forgets, and this forgetting is not just metaphorical, it is literal, unfolding beneath our feet every day. The Earth is not a museum. It does not keep archives. It does not preserve relics, nor does it hold any care for memory. Instead, the planet is a relentless destroyer of records, patient, unfeeling, and unstoppable. It covers, erodes, crumbles, melts, and subducts. Even the crust, the solid stage on which every act of life has played out, is not permanent. Tectonic plates drift slowly but constantly. They collide, slide beneath each other, and renew ocean floors as one plate is pushed under another. Continents themselves are consumed and reformed. Mountains rise majestically, only to be ground into dust over millions of years. Volcanoes can bury entire landscapes in a moment, only to disappear beneath new layers formed long after. What is land anyway? What appears solid and permanent today may have been ocean yesterday and could be desert tomorrow. Rocks do not remember names or stories. Consider the Atlantic Ocean. It did not exist 200 million years ago. Its seafloor, every ridge, every trench, every sediment layer is younger than that. The crust that once supported the supercontinent, Pangaea, has long been swallowed beneath it. Whatever once existed on those vanished surfaces has been crushed and melted deep in the Earth's molten interior. The oldest oceanic crust on Earth is barely 280 million years old, with most being far younger. This is what makes the Sorian hypothesis so frustrating. We ask, if an ancient intelligent species existed, where is the evidence? But the better question might be, how could any evidence possibly survive to be found? Now imagine a future geologist, 100 million years from now, studying a transformed Earth long after humanity is gone. Civilizations have risen and fallen, cities crumbled to dust, climates warmed and cooled, oceans have shifted, new ecosystems emerged. Perhaps mammals have been replaced by birds, cephalopods, or forms of life we can barely imagine. This distant scientist digs into the sediment and uncovers a fleeting chemical anomaly, a thin layer rich in unusual carbon isotopes, traces of plastic polymers, a spike in extinction rates, a sudden disappearance of megafauna. Maybe there is a faint degraded signature of radioactive isotopes from atomic testing. They speculate, is this a natural event, a comet impact, a volcanic eruption, or something else entirely? Without artifacts or witnesses, how can they be sure? The trail ends in silence, the story unfinished. This is what deep time amnesia looks like. It is the greatest barrier to truly understanding Earth's past, and it is utterly merciless. Even the bones of dinosaurs, once rulers of the planet for over 165 million years, survive only in select locations, often crushed, fragmented, or incomplete. What then of an intelligent species that didn't dominate the planet, but merely inhabited a region or a brief era and then vanished? There may have been dozens, even hundreds of such civilizations, all lost without a trace. Adding to this geological forgetting is another kind of blindness, confirmation bias. We tend to find only what we expect, explaining oddities within familiar frameworks and dismissing what does not fit. If a layer of fused minerals appears in Permian rock, we assume volcanic glass. Strange shapes in sediment are labeled natural concretions. If a tool-like object is discovered in coal, we suspect contamination or modern intrusion. Science's caution is its strength, but in the depths of time, caution can become blindness. We fail to see what we are not searching for.
This raises a darker question. If intelligent life did arise before us, building, learning, creating and perishing, might we have already found evidence without recognizing it, then buried it again with disbelief? Imagine an ancient city not built of stone, but of coral-like biostructures that dissolve in air. A power system based not on combustion but on microbial energy, leaving no chemical scars. Transportation not on roads but via fungal networks or magnetic fields. Communication through bioluminescent patterns or quantum resonance. None of this would fossilize. None would leave behind structures we could recognize. What have we missed? What existed before us? And if Earth tried to speak, would we hear? Or would we cover its voice again beneath asphalt and concrete, burying the last trace of a civilization that once was, and now, once more, is not?
A coral reef, after all, can be thought of as a kind of city, an intricately organized community. Similarly, a beehive represents a highly structured colony, and termites construct elaborate mounds with ventilation systems rivaling those of modern skyscrapers. Yet, despite these remarkable natural architectures, we do not label these creatures' creations as civilizations because of the species involved. This bias constrains us. We tend to expect civilization to resemble our own: straight-edged buildings, sprawling electrical grids, the residues of combustion and industry. But what if an ancient species developed along a radically different path, one of biological integration rather than mechanical dominance? What if their entire way of life functioned as a closed-loop ecosystem, leaving no lasting physical trace behind? What if they intended to leave none? Such a scenario is not outside the realm of possibility. In fact, it might be quite prudent, because the more destructive a civilization becomes, the more traces it inevitably leaves. Yet paradoxically, that same destructiveness often sows the seeds of its own downfall. To be seen, to leave a mark, might doom a species to extinction. Perhaps a civilization capable of sustainable technological intelligence would have had to master harmony with their environment rather than conquest over it. This leads us to a haunting prospect. If a species ever attained advanced, sustainable intelligence, if they mastered matter, energy and biology without devastating the planet, then we may never know they existed. They could be invisible to the slow, grinding mechanisms of time. Even worse, if some subtle clue did survive, would we be capable of recognizing it? Consider this thought experiment. In 1961, a nuclear explosion in Nevada melted desert sand into glass, a small, inert, featureless disk buried beneath layers of dust. If a geologist 100 million years from now were to discover such an object, would they conclude it was manufactured or natural? Would it simply be dismissed as a geological oddity? Now reverse the scenario. If a similar glassy disk were found embedded in rock dating from the Permian period, how would we explain it? Volcanic glass, a lightning strike, a rare natural event. Humans excel at rationalizing away the unexpected. The paradox of the fossil record is not merely that too little has been preserved, it's that we may have already uncovered fragments of ancient civilizations but rejected them as anomalies or noise. Strange tools found embedded in coal seams, geometric patterns in deep strata, metallic spheres extracted from ancient mines. These are all documented discoveries. Yet most are dismissed as curiosities, hoaxes, or misidentified minerals. Our conditioning makes us blind to intelligence in the deep past. When we claim there is no evidence of past civilizations, we must be careful to understand what this truly means. No known evidence has been found within the accessible and interpretable layers of rock studied so far. That is not the same as saying evidence does not exist. Absence of evidence is not evidence of absence, especially in a record where silence is the norm. So where does this leave us? Adrift in deep time, searching a shattered mirror for a reflection that might never have looked like us at all. It should leave us humble, because we are not the masters of history, we are merely the latest sentence in an unfinished story. Previous chapters may have been erased, not out of malice or conspiracy, but through the indifferent forces of time, water, heat, and geological change. Yet the paradox remains. If we cannot see these hypothetical precursors, how can we be certain they never existed? Perhaps we cannot. But maybe the clues do not lie in ancient bones, but in the very chemistry of the Earth itself, strange spikes, elements out of place, subtle chemical whispers of fire, metal, and transformation. This is where our search must turn next. Into the soil, the air, and the scars etched into Earth's memory. Here, the fingerprints of industry might linger, even if the hands that left them long ago turned to dust. What would civilization smell like? If you could peel back the layers of time and breathe in the atmosphere of the mid-21st century, what scents would fill your lungs? The acrid tang of burnt carbon and smog, the sharp bite of ozone, trace metals and synthetic compounds drifting invisibly through the air, a chemical fingerprint of progress or perhaps collapse. If intelligent life existed millions of years ago, it too might have left such a scent, not in the ever-shifting air, but locked in rocks, sediments, and isotopes embedded in the Earth's crust. This is the realm of geochemistry, a kind of planetary forensic science. If we are to hunt for the ghosts of ancient civilizations, this is where we must begin, sifting quietly and carefully like archaeologists searching through ashes for a spark. Suppose a pre-human civilization existed and harnessed energy like us, burning carbon, mining metals, refining chemicals. Then some trace of their activity should remain, and perhaps some already does. Let's start with the obvious. What do we leave behind? Carbon dioxide emissions, plastic pollution, nitrogen from fertilizers, rare earth elements, isotopic shifts skewed by combustion, artificial radionuclides from nuclear tests, layers of concrete, microbeds, aluminum fragments, refined, shaped, and scattered. We are altering Earth's chemistry on a geological scale. Indeed, many scientists argue we have entered a new epoch, the Anthropocene. Consider one well-known example, the Paleocene-Eocene thermal maximum, PTM, roughly 56 million years ago. During this event, global temperatures soared by 5 to 8 degrees Celsius within a few thousand years, a mere heartbeat on a geological scale. Massive carbon was released, oceans acidified, ecosystems were disrupted, species migrated or went extinct. Recovery took over 100,000 years. What caused this dramatic event? Volcanic activity? Methane release from ocean floors? Or something else entirely? Could this have been the exhaust of a long-lost civilization burning through its carbon reserves? It is speculative, but that is precisely the uncomfortable question the Sorian hypothesis dares to ask, challenging settled assumptions. Another modern signature is plastic. Humanity produces over 400 million tons of plastic annually. These polymers resist decay. Some plastics accumulate in oceans, some fill landfills, others are incinerated, but a vast amount breaks down into microplastics, tiny particles drifting through soil, water, and air. Over time, these microplastics may become compacted into sedimentary rock. Geologists have already named such mixtures plastic glomerates. heat-fused conglomerates of plastic and natural material like sand or coral. If plastic glomerates survive in the geologic record, they could serve as unmistakable markers of our presence. Now ask, if we discovered something similar in ancient rocks, would we recognize it? Or would we dismiss it as a natural curiosity? Then there is the question of nuclear signatures. Nuclear weapons testing in the 20th century produced artificial isotopes like plutonium-244 and cesium-137 that do not occur naturally. These isotopes have varying half-lives. Some vanish in thousands of years, others persist for millions. Imagine a civilization 100 million years ago using nuclear technology on a large scale. Could traces of their artificial isotopes survive? We have a real-world analog, the natural nuclear fission reactors at Oklo, Gabon, which operated about 2 billion years ago. Natural uranium deposits sustained chain reactions for hundreds of thousands of years, leaving unmistakable geochemical fingerprints. If nature can do this, so might an intelligent species. If we were to find evidence of an ancient nuclear age, unusual isotopic ratios of uranium, thorium, or cesium in ancient rocks, they might look just like Oklo's signature. The question would then become, who lit the fuse? Mining activities leave traces too. Concentrated rare earth element deposits, tailings of processed metals, unusual isotopic concentrations from refining, all potentially detectable in the rock record. But here lies the great challenge. Geology is violent and dynamic. Plate tectonics churn the crust like dough. Erosion relentlessly scours landscapes. Mountain building and volcanic activity erase and remake the surface. The ocean floor, the planet's largest geological archive, completely recycles every 200 million years. This means Earth's surface has been entirely replaced at least once since complex life emerged. That is the greatest obstacle. Even if a civilization burned fuel, refined metals, and radiated energy, their signals may now be fragmented across shifting tectonic plates, buried beneath kilometers of sediment, or erased altogether. Some signals endure, but are they artificial? Here is the uncomfortable truth. We do not have a definitive baseline. We do not know what the chemical signature of a lost civilization would look like, especially if it was fundamentally different from ours. What if they never burned fossil fuels but harnessed geothermal or tidal energy? What if their industries were organic rather than metallic? What if their waste was biodegradable or even recycled? What if they cleaned up after themselves? In such cases, we might find nothing but subtle echoes, chemical disturbances that don't quite fit our models, sediment layers that shift expectations, isotopic ratios that puzzle us, data points dismissed as geological noise. We might already be observing their footprints and calling them natural anomalies. The irony is profound. We too will become a geological anomaly, a thin black line in sediment, a plastic fingerprint, a spike in carbon isotopes, a ghost of electricity and flame. If we are the first, we set the standard future archaeologists will use to judge unknown civilizations. But if we are not the first, if others once lit the earth with machines and fire, we might be digging through their remains every day without realizing it.
So we continue searching. In soil, in seas, in isotopes, not for bones or ruins, but for the chemistry of ambition. Because civilization in the end may be less about monuments and more about molecules, and those molecules might still be whispering to us.
Beneath our feet lie scars, not from war or weather, but etched into the very fabric of time. These scars tell stories not in words, but in ratios: carbon, oxygen, sulfur, traces of ancient atmospheres preserved in stone like a planetary confession. And occasionally these stories take a sharp turn, a spike, a rupture, an unnatural deviation in carbon levels that disrupts Earth's usual rhythm. Scientists call these carbon isotopic excursions, geological events where the ratio between carbon-13 and carbon-12 changes suddenly and dramatically. To the trained eye, they resemble heart attacks in the geological record. And like any good detective, the question arises, what caused this? One of the most famous such spikes occurred 56 million years ago during the Paleocene-Eocene thermal maximum, or PETM. Within just a few thousand years, barely a blink in geological terms, Earth's temperatures surged by 5 to 8 degrees Celsius, sea levels rose, oceans acidified, entire species migrated or vanished. This upheaval is recorded clearly in a dramatic shift in carbon isotope ratios, revealing how carbon cycled through the atmosphere, oceans, and biosphere. A sudden surge of lighter carbon isotopes, specifically carbon-12, suggests a massive release of methane or organic carbon into the atmosphere. Something either burned, decomposed, or was unleashed from the depths of the Earth. Traditionally, we attribute such events to volcanoes, methane hydrate destabilization, or shifts in Earth's orbit. And perhaps those explanations are true. But the Sorian hypothesis dares to ask, what if something else caused it? What if, 56 million years ago, Earth ignited because someone lit the match? Imagine an ancient civilization, industrial in scale, powered by fossil fuels consuming carbon, flourished and then collapsed. The carbon spike they created might look strikingly similar to what we observe at the Paleocene-Eocene thermal maximum, PETM. Here's the catch. Carbon doesn't carry a label stamped volcano or factory. It leaves no explicit signature. But the effects, the warming, the extinctions, the acidification, they look eerily familiar. They resemble what we see unfolding today because, in effect, we too are creating a carbon spike. When we look back at the PETM or at other unusual geological anomalies such as the Permian-Triassic boundary, a chilling symmetry emerges. The Permian-Triassic extinction, sometimes called the Great Dying, wiped out over 90% of marine species and nearly 70% of terrestrial life. It also produced one of the largest carbon isotope shifts in Earth's history. The usual suspects, volcanoes, specifically the Siberian traps, massive eruptions that darkened skies and poisoned oceans. But how much of this narrative is certainty and how much is assumption? If we humans disappeared tomorrow, if every machine fell silent, future civilizations would find a similar carbon spike. They might assume it was volcanic too. But it wouldn't be. It would be us. So the question is not only what caused these spikes, but are we certain we interpret them correctly? What if intelligent life leaves behind only indirect traces, subtle chemical distortions rather than towering monuments? Then these carbon spikes might not be geological side effects but epitaphs. And here's where it gets stranger. The PETM was not the only spike. There have been many others, some lasting thousands of years, others much shorter, like the Torsion Oceanic anoxic event or the Midian event. Each featured bursts of warming, mass extinctions, and disrupted carbon cycles. Each might be a whisper from a vanished civilization, though these whispers are faint, not shouts. The further back in time they occurred, the quieter they become. Over millions of years, rock layers compress, signals blur, clues erode. What remains are ghost fingerprints, traces without context, but the signal endures, a repeating pattern of carbon outbursts, planetary fever, then silence. Civilization, if it existed, may burn bright, but briefly, leaving behind a signature of fire. The frightening part is that we are currently writing our own chapter of this story. Future geologists, if any survive to study us, will see the same pattern. A sharp rise in carbon-12, global temperature spikes, ocean acidification, mass extinction, all unfolding in real time. They might not know we were here, but they'll know something happened. They will wonder, as we do now, could someone have come before us? And if so, did they burn their world too? But perhaps there is another perspective. What if these carbon spikes are not simply signs of collapse, but signals of transformation? Moments when the Earth resets itself, sometimes violently, after being pushed too far. Not because life is weak, but because intelligence is unstable, a phase, not a permanence. If so, civilization might always end in fire, and each spike might be a requiem, a final message sent not into space, but into time.
So what does this mean for us? It means we are not just leaving behind emissions, we are leaving a mystery, a test. Will those millions of years hence read the rocks as we do and ask if they're witnessing ghosts? Will they see the carbon and ask, did it come from volcanoes or from hands? Will they find other spikes, older, deeper, inexplicable? We don't know. But the spikes are real. They are waiting for us to decode them or to become one.
252 million years ago, Earth came as close as it ever has to becoming a dead planet. It was the end of the Permian period, a time when strange creatures roamed sprawling ecosystems. Trilobites still scuttled across ocean floors. Ancient reptiles stalked fern-covered continents. Life had flourished for hundreds of millions of years, evolving into a complex tapestry. And then the sky darkened, oceans turned acidic, and the land fell silent. This was the Great Dying, the largest extinction event in Earth's history. Over 90% of marine species vanished. On land, nearly 3/4 of all life disappeared. Forests collapsed, coral reefs were obliterated, the planet teetered on the brink of lifelessness. Geologists have long blamed the Siberian traps, one of the largest volcanic events ever recorded. Massive basalt floods blanketed what is now Siberia. Over 1 million years, eruptions spewed carbon dioxide, sulfur dioxide, and methane into the atmosphere, driving global temperatures to catastrophic extremes. Acid rain scorched the land. Oceans became anoxic, vast dead zones spreading. It's a compelling theory, but what if it's incomplete? What if the Siberian traps were the trigger, not the cause? The Sorian hypothesis dares to ask a forbidden question. What if something intelligent had already pushed Earth to the edge before the lava flowed? After all, our own civilization has released carbon into the atmosphere at rates faster than any natural process on record, in just over a century. The Industrial Revolution ignited a furnace that still burns today, leaving a measurable geochemical signature. Now imagine a similar species, carbon-based and industrial, oblivious or indifferent to the consequences of its actions, doing the same millions of years ago. Could their recklessness have destabilized the planet, setting the stage for volcanic catastrophe? Strangely, carbon isotope data from the Permian-Triassic boundary shows signs of a rapid and massive influx of carbon-12, just like today. The die-off was not slow. Some extinction layers suggest it happened in tens of thousands of years or less, a lightning strike, an ecological freefall. One leading hypothesis proposes that methane hydrate deposits, ice-like compounds at the ocean floor, were destabilized, releasing vast methane volumes. This, combined with CO2 from the Siberian eruptions, triggered a runaway greenhouse effect. But again, we must ask, did something push the first domino? Nature is brutal but rarely reckless. It operates in cycles, feedbacks, checks and balances honed over eons. When Earth tips into chaos, it usually needs a shove. What if that shove came from minds? Not like ours, perhaps not human, but intelligent, tool-using, energy-consuming life that rose and fell long before humans stood upright. If true, the Great Dying was not merely extinction, it was a reset, a planetary purge of a species that lost control. What might they have looked like? We can only speculate. Perhaps reptilian, descended from early archosaurs, or marine, building cities deep beneath the waves. Maybe their technology wasn't based on metals or wires, but on organic chemistry, bioengineered structures, or sonic resonance, things that leave no obvious trace but whose consequences remain. Those consequences are visible: temperature rises, collapsing food chains, biodiversity loss, carbon layers embedded in rock, a signal burned into Earth's crust like a funeral pyre. We are now living through a parallel moment. Our oceans warm, species vanish, coral reefs bleach and die. CO2 levels exceed 420 parts per million for the first time in millions of years. If we vanished tomorrow and Earth healed over our ruins, future scientists would see this spike, this bottleneck, and wonder what happened. If they dared to speculate, they might conclude something intelligent once lived here and lost control. That's exactly what the Permian record shows. It's not proof, but it is symmetry. Nature loves symmetry. Of course, it might truly have been just volcanoes, Siberian traps, the roll of a planetary dice, that the biosphere couldn't withstand such scale. But volcanoes don't explain everything, not the speed, severity, timing, or the striking resemblance to the fingerprints we leave today. So maybe, just maybe, the Great Dying was not only the end of an age, but a warning, written in fire, etched in ash, left for anyone willing to read between the layers. Because if we are the first, this is our only trial. But if we are not, then this is our second chance, and we should ask ourselves, what did they do wrong? Are we repeating it? The planet always survives. It is civilization that does not. What if apocalypse is not a bang, but a process, a slow, crumbling descent into silence, a flickering light bulb before blackout? What if civilizations don't vanish instantly but disintegrate, pulled apart piece by piece, system by system, until all that's left is a whisper beneath the rocks? This is the ghost we fear most. Collapse from within. And it may already be haunting us. For the Sorian hypothesis to hold weight, we must confront a darker possibility. Intelligence does not guarantee survival. The very spark that births civilization can also be its undoing. Somewhere deep in Earth's past, another species may have risen, reached and fallen, not to asteroid or plague, but because their own brilliance outpaced their restraint. There are patterns we know all too well: resource depletion, runaway climate change, technological addiction, fragile global systems that seem unbreakable until they break. And maybe those patterns have already played out. Imagine a civilization built on energy like ours, not human, not primate, but perhaps reptilian, avian, or stranger still. Their tools may not have resembled ours. Their cities might not have gleamed with glass and steel, but they would have left fingerprints in carbon, isotope anomalies, sudden geological shifts. Picture this: a civilization that burns too fast, discovering a world of stored sunlight, ancient hydrocarbons trapped beneath rock, and unleashing it. Maybe they didn't call it oil or coal, but they exploited it all the same. For a time their world flourished. Populations soared, structures rose, the planet bent to their will. They climbed a technological arc that crested high and then wavered, because with energy comes dependency, and with dependency comes collapse. We know how it might happen. Feedback loops spiral out of control, ice melts, seas rise, crops fail, conflict erupts, infrastructure cracks under pressure, governments falter, people turn inward, supply chains snap, lights go out, communication ends, and no one is left to keep the fire burning. Sound familiar? We've seen this story in miniature, in empires that fell to overreach, in societies that consumed themselves. Easter Island, the Maya, Mesopotamia, Rome, their collapses were echoes. But what if long ago there was a louder version, one that shook the entire planet? Today, our machines hum with invisible electricity, our data flows silently, our systems seem omnipresent yet depend on delicate threads: silicon, power, cooperation, stability. Pull one thread and the whole thing unravels. A digital civilization is a ghost waiting to happen. Hard drives rot, servers corrode, cables decay. In 1,000 years, no one will remember what those blinking lights meant. In 1,000,000 years, not even dust will remain. So if an ancient civilization advanced digitally, what would they leave behind? Maybe not much, maybe nothing. Just anomalies, layers of unexplained isotopes, disruptions in ocean chemistry, traces of altered atmosphere, signs that something once pushed the planet out of balance but left no skeletons to explain how. Like a machine that ran too hot and burned itself out. This is the ghost in the machine, the invisible collapse, one that doesn't scream but size. And here's the haunting part. We might be living it again. Right now, the Anthropocene is becoming geologically legible. We are leaving behind a planetary fingerprint. Plastics embedded in sediments, nitrogen spikes in soil, rare earth metals in concentrations never seen before, technofossils made of alloys nature never forged. In 100 million years, someone or something might drill a core sample and find the year 2025 marked as a sharp line of strange. They might ask, what happened here? Was it natural? Or was it a folly? Maybe they'll theorize, as we do now, that intelligence flickered briefly on Earth once or twice and extinguished itself before it could reach the stars. Maybe civilizations don't die dramatically but fade. First infrastructure fails, then food supplies, then trust, then memory, and finally silence. The idea isn't new. Philosopher and mathematician Alfred North Whitehead once said, "Civilization advances by extending the number of operations we can perform without thinking." But perhaps in that very automation, we lose resilience. We create systems we no longer understand, and when they break, we can't fix them. What if the ancient ones suffered the same fate? What if they built something magnificent, a world of lights, music, and mind, and it all depended on a few brittle threads? When those snapped, their history unraveled with them. It's possible their collapse was gentle. No war, no fire, just dwindling food, less light, fading hope until the last city crumbled into forest, until memory became myth, and myth faded into nothingness. The earth turned uncaring. Now we stand again on the edge. We've built our own machine. It hums and pulses and sings across the globe. But already we see the ghosts, data rot, energy shocks, climate tipping points, fragile supply chains, rising seas, algorithmic chaos. We look around and think, this can't end. But that's what everyone thinks, until it does. And that is the final lesson of the Sorian hypothesis. Civilizations don't just leave ruins, they leave absences, questions. If we're not careful, we'll leave the same ones. If a civilization falls in a forest and no one is around to hear it, does it leave ruins? This is the question that haunts the Sorian hypothesis. Not just did it happen, but if it did, why can't we find it? We expect monuments. We search for shattered towers or buried cities. Our imaginations reach for stone, metal, bone, something material, something human. But what if the ruins of a non-human civilization don't look like ours? What if they don't last? The Earth is efficient in its erasure. Cities dissolve, metals corrode, satellites fall, roads vanish, glass turns to dust. Consider how little of our own civilization would remain after just a few million years. A steel bridge might crumble in 500 years. Skyscrapers would be rubble even sooner. Concrete would fracture and fade within 100,000 years. And beyond that, history dissolves into fog. Stretch the clock further. 1 million years, 10 million, 100 million. This is the timescale we're dealing with when we talk about the Sorian hypothesis. Not centuries, not millennia, but geological epochs. Could any evidence survive? Perhaps, but not in ways we're used to looking for. We dig for bones and pottery. We scan for ancient walls and roads. But what if ancient intelligence didn't build with stone or metal? What if they lived differently, in megastructures grown from biology, cities shaped from genetically engineered trees, energy harvested from microbial mats, leaving no traditional artifact behind? We're biased toward our version of intelligence, tools, fire, architecture. But intelligence isn't a blueprint, it's an adaptation. Evolution doesn't repeat itself with precision. A civilization might have emerged in the Permian or Devonian that never invented the wheel but still built wonders. It might have sung through fiber optic vines or written its story in quantum pulses across living organisms. And when it died, nature reclaimed it without a trace. Even our own most enduring creations, digital data, nuclear waste, satellite constellations, have shelf lives. Radiation fades, disks rot, orbits decay. So what would truly remain? Maybe just a layer, a narrow band of sediment touched with rare isotopes or unexplained chemical ratios. A subtle signal, easy to miss. Maybe we've already drilled through it, mistaking it for volcanic ash or oceanic turnover. Maybe we've seen the ruins and didn't recognize them because silence isn't empty, it's filled with assumptions. We assume we'd know an artifact if we saw one, that evidence must be legible. But what if the ruins of an ancient civilization aren't monuments but puzzles? An unexplained pattern in carbon, a sudden spike in rare earth elements, a gap in fossil records, a zone of chemical disequilibrium that doesn't fit climate models, ruins hidden in chemistry. We've already begun discussions about what messages we should leave behind, warnings for our nuclear waste, symbols carved into stone meant to last 10,000 years. Glyphs designed to be unreadable by accident but clear in intent, danger, not treasure. If we think about legacy, why wouldn't they? Perhaps they encrypted their ruins, buried them deep, designed them to be indecipherable until a future intelligence proved itself worthy or avoided their fate. Or maybe they chose a more haunting route, total silence, no monuments, no warnings, no trace, a deliberate unmaking. After all, what is history but the stories we choose to tell? If a civilization died knowing its story would be distorted, turned into legend, or worse, justification for violence, maybe they decided not to tell it at all. And yet, silence can be louder than noise. There are gaps in the geological record. We can't explain anomalies that don't align, isotopic signatures hinting at high-energy events without cause, fossils that appear, vanish, reappear. These are not smoking guns, but they are questions, ones that whisper of ghosts. Ghosts we may never fully meet. But that doesn't mean they weren't here. It just means the ruins they left aren't built for our eyes. They're written in the language of time. If the earth holds secrets, then the ocean is where it whispers them. Beneath the surface, beneath the silence, beneath even the reach of sunlight lies a record not etched in stone or ink, but in layers of sediment, built slowly like the soft exhalation of time itself. Every grain of silt, every microscopic shell, every fleck of organic decay falling from above becomes part of the seafloor's memory. And yet, this memory is nearly untouched. We've mapped Mars more thoroughly than our own ocean floors. The deepest trenches remain dark to our eyes. The mid-ocean ridges are mysterious, and the vast, flat, abyssal plains, covering more than half of the Earth's surface, are still largely unexplored. If a previous civilization once lived and died on this planet, the evidence of their existence may not lie in deserts or mountaintops. It could be buried beneath kilometers of water and mud, for the ocean does not forget as easily as the land. While continents shift and erode, oceans preserve. While forests rot and jungles swallow cities, deep-sea sediments settle gently and remain undisturbed. In some places, sediment accumulates so slowly, just a few millimeters per 1,000 years, that an undisturbed layer may contain a snapshot of an entire epoch. Within these layers, anomalies hide, strange shifts in carbon, unusual concentrations of heavy metals, isotopic spikes without volcanic cause, moments in geological history that seem to shout, yet whose language we have not yet learned. Consider the Paleocene-Eocene thermal maximum, a sharp global warming event 56 million years ago. It left behind chemical fingerprints that still baffle scientists, gigatons of carbon released into the atmosphere, ocean acidification, extinctions, but no clear cause. Could it have been natural methane release or something else entirely? What if the ocean floor is hiding the remains of a long-dead civilization, not buildings, but byproducts? A buried plastic layer, synthetic compounds, radioactive particles, or subtle changes in foraminifera shells caused by ancient industry. We have drilled only the tiniest fraction of the sea floor. Most remains untouched, its secrets wrapped in layers of sediment that may never be disturbed unless we choose to look. In 1985, a team studying the seabed near the Azores found what appeared to be rectilinear features, geometric patterns in the sediment too structured to be natural. They were dismissed as coincidence. Yet others have reported similar anomalies off the coasts of India, Japan, and even the Caribbean. None are confirmed, all remain controversial, but the whispers are there. The ocean remembers everything, but it does not volunteer its memories easily. To access its archive, we need better tools, autonomous submersibles, deep-sea drills, high-resolution sonar. And we need a new mindset, one that accepts the possibility that our own species is not the only story Earth has told. What if the first intelligent civilization on Earth didn't look anything like us? We tend to picture aliens as humanoid, bipedal, upright, roughly symmetrical. When we imagine ancient Earth civilizations, we often do the same. But nature rarely repeats itself so neatly. Evolution is not a blueprint, it's improvisation. Earth's 4.5 billion-year jam session had plenty of time to riff before we ever showed up. If intelligence arose before humans, it may have emerged from forms that no longer exist, creatures shaped by ecosystems long since dismantled, or even realities we can barely imagine. Consider the Devonian period, 400 million years ago, when forests spread for the first time. Giant arthropods roamed the land, seas were filled with armored fish. What if, in a shallow estuary, a cephalopod ancestor of the squid developed complex problem-solving, a civilization that built not cities of stone, but soft coral pens, kelp enclosures, algae farms? Such a civilization wouldn't leave stone ruins or tools and might not even leave bones. Now imagine a silicon-based technology, not made of metals and plastics, but crystalline structures grown, not forged, light-sensitive, self-replicating, biodegradable. A civilization built on photonic logic and neural resonance, thriving for millennia before dissolving into the sediment, indistinguishable from nature. Would we recognize such technology? Or would we dismiss it as a geological curiosity, a strange crystal formation, a trick of erosion? Let's go deeper. What if intelligence itself was not localized? We define consciousness in terms of brains and central processes, but what if an ancient life form had distributed cognition like fungal mycelium, coral reefs, or slime molds that solve mazes without neurons? Could an entire forest have once thought slowly, communicating through chemical signals and seasonal rhythms? A global network of sentient organisms, invisible to the naked eye, pulsing with long-wave memory across millions of years. Perhaps this life didn't build machines or leave monuments. It left balance, harmony with the biosphere, stability in the climate. Its art was the long curve of co-evolution. Its ruins were forests and reefs. Then something changed, a cosmic impact, a shift in temperature, a competing species. This alien, earthborn, non-technological civilization faded not in war or flame, but in silence. It was absorbed, decomposed, transformed into soil and seed. There's another possibility. Intelligence evolved deep underground. We think of life as surface-bound, but bacteria thrive miles beneath the crust. Entire biospheres exist in deep rock aquifers. What if something adapted to the subterranean, dark, sensitive to vibration, heat, magnetism, communicating not with sound, but with pulses of current through conductive minerals? Life shaped by the void, using geothermal vents as power, encoding pulses in crystalline lattices. Would they care to explore the surface? Would they recognize it as habitable? Maybe they lived in silence for hundreds of millions of years until the crust shifted and their networks were broken. Maybe they still exist beneath our feet, sleeping in data forms we can't decode. We assume intelligent life leaves behind great works, cities, satellites, monuments, but this is human projection. Our own short-lived empire of steel and silicon has lasted barely a century, a blink in geological time. Why should others follow the same path? A non-human civilization might have been entirely aquatic. No fire, no metallurgy. Technology developed through sound, pressure, and hydrodynamics. Picture sonar-based engineering structures formed by controlled currents, language encoded in pulses of vibration traveling for miles underwater. Nothing survives, yet perhaps they left behind patterns, harmonic signatures embedded in sediment, strange arrangements of mineral density on the seafloor, things we might never think to look for, things we might already have seen and dismissed. Could intelligence have evolved more than once in completely unrelated species? The octopus, for example, split from our evolutionary line hundreds of millions of years ago. Today, it exhibits tool use, play behavior, memory, and problem-solving. It is, in some ways, a thinking alien already here. What if one of its ancestors went further? What if, before the continents drifted to their current shapes, a cephalopod civilization arose deep in a now-vanished ocean? Their knowledge not preserved in books, but in color-shifting skin, generational mimicry, and choreography. They built nothing but remembered everything until extinction came. It could have been a comet, a methane burst, or simply time. Currents changed, reefs collapsed, and minds faded until only echoes remained, in instincts and ink. There may have been minds on this world long before us, minds that dreamed, wondered, and reached in forms we can barely conceive. Their stories are not written in books or bricks, but in the deep structure of the Earth itself, in the sediment, in the DNA, in the unexplained, waiting. If an ancient civilization once rose on Earth long before our own, would it have tried to leave something behind? We like to think knowledge yearns to endure, that if an intelligent species had built, dreamed, calculated, or discovered, it would want others, perhaps future beings, to know, even if that meant communicating across tens or hundreds of millions of years. And so we ask, could they have left a message, a time capsule, not just a mark of their presence, but a warning or a gift? The problem, of course, is time itself. Nothing we build today, no monument, no archive, no satellite, is guaranteed to survive the slow crush of geological time. Our strongest alloys will corrode, our books will decay, our data centers, buried or not, will be erased by entropy. But what if they knew this? What if a prior civilization, far older and wiser, understood the futility of leaving behind traditional monuments and instead turned to other means? Imagine knowledge encoded not in stone, but in biology.
DNA is nature's storage medium. It compresses extraordinary complexity into just a few molecules. Today, we know it can be used to encode arbitrary information, images, audio, even entire books. It is resilient, redundant, and already embedded in life itself.
What if a previous species wrote their legacy into the genes of organisms that could survive mass extinctions? Microbes, perhaps extremophiles, bacteria that live in volcanic vents, or spores that endure cosmic radiation, life that could drift through catastrophe and still replicate. Would we even recognize that message? Could segments of our own genome, those parts often dismissed as junk DNA, actually carry structured, intentional information patterns? Patterns that might seem arbitrary to us but could be language to another mind. Or perhaps the knowledge was stored in a form beyond biology, in physics itself, resonance patterns embedded in crystal lattices, neutrino pulses fired into stable orbits, or quantum entanglements seeded deep within the Earth's materials. These ideas sound like science fiction, but they are not beyond the reach of theoretical physics. What truly matters isn't whether we can decode such messages now, but whether someone once meant for them to be found. Let's go deeper still. What if the message wasn't passive, waiting silently to be discovered, but active? What if an ancient civilization didn't just store information, but engineered systems designed to awaken under specific conditions? Autonomous programs, self-replicating machines made not of metal, but of biopolymers, dormant until triggered by heat, radiation, or chemical cues. We might call them mimetic seeds, ready to bloom when the world resembled theirs once more. What if they seeded memory into the Earth itself, buried deep within tectonically stable regions, far from subduction zones, inert structures encoded with knowledge but sealed behind geological thresholds? Accessing these would require not just digging, but civilization-level intelligence. Once the tools exist to uncover it, the structure would activate and the message would begin. This is not mythology. This is strategy, an insurance policy, a final signal from a species aware of how easily time swallows everything. Of course, there is a darker side to this theory. What if the knowledge wasn't meant for us? What if it was meant for them, a future version of themselves? Consider the idea of directed panspermia, seeding the galaxy with microbial life to ensure survival beyond extinction. A prior civilization might have viewed their presence on Earth as temporary, cyclical, or even experimental. They may have encoded their essence, biological or digital, into the biosphere, awaiting conditions to regenerate. We may not be the inheritors of their knowledge. We may be their reboot, and we may not even know it. Returning to the surface, think of the oldest known human structures: Göbekli Tepe, the pyramids, Stonehenge. We marvel at their endurance, yet they are all under 15,000 years old, a mere blink in Earth's history. If you wanted to preserve something across 100 million years, you wouldn't build upward, you'd build downward. Deep caverns, shielded pockets in stable continental cratons. Not large but precise, containing not machines but patterns, geometries, encoded logic, maps of thought, a seed library, not of plants, but of ideas. Are we looking in the wrong places? Are we so obsessed with monuments and pyramids that we overlook subtlety? Perhaps the time capsule has already been found, misclassified as a geological oddity, an unexplained formation, a mineral deposit with patterns that don't align with natural processes, a magnetic anomaly beneath Antarctic ice. Something strange spotted by satellites but dismissed by algorithms, stored away in forgotten databases. Or maybe it's still out there, and maybe they placed it on the moon. Earth's surface is dynamic, but the moon is dead, airless, still, and ancient. Anything left there stays preserved. Civilization might have seen this clearly and reached for the nearest beacon. If we ever find an artifact in the lunar regolith that predates humanity even by 1 million years, the implications would ripple across everything. We search for signals, but maybe the signal is this moment, the act of looking, the realization that we might not be the first. That knowledge can survive in whispers, in echoes, in dormant seeds, waiting for the right minds to awaken them. So we dig, we wonder, we question, and somewhere, maybe something listens. We gaze into the stars and wonder why they do not gaze back. This is the Fermi paradox, a simple question so endlessly unanswered. Where is everyone? With billions of stars in our galaxy alone, many older than our sun, and a universe teeming with planets, logic suggests we should not be alone, not by a long shot. Even at a crawl, an advanced civilization could spread across the stars in mere millions of years. So where are they? Maybe we're asking the wrong question. Maybe it's not about them, but about us. Or rather, those who came before us. What if the great silence isn't out there in the cold void beyond the stars, but behind us, buried in the rock and dust beneath our feet? Returning to Earth's layered memory, there are chemical spikes in ancient strata, anomalous isotope ratios, abrupt carbon fluxes, rare elements that suddenly vanish. Geologists have found such signatures, often attributing them to volcanism, asteroid impacts, or natural methane releases. But what if one of those layers isn't natural? What if buried within that noise is the whisper of something else? A short-lived burst of industrial activity, a civilization that flared, faltered and faded, leaving behind no towering monuments or bones, only a quiet chemical residue, a ghost in the geologic record. We wouldn't need to see buildings or bones. All we'd need is a pattern that doesn't belong. Here's the twist. We might have already found it and looked away. Scientific paradigms are powerful. They define not just what we see, but what we are willing to consider. Proposing an ancient pre-human civilization isn't just radical, it's heretical. It challenges archaeology, paleontology, and human exceptionalism. Yet science should challenge itself. If evidence exists, even faint, fragmented, or circumstantial, we owe it to ourselves to ask, what if the Fermi paradox has already been answered? What if civilizations do arise but burn brightly and briefly, leaving behind only scars, not just across the galaxy, but on their own home worlds? This reframes the silence. It suggests intelligence may not be a solution, but a phase, an unstable flash of complexity that nature tolerates only for a moment. When it ends, the biosphere closes over it like a wound. Time moves on. If that's true, the reason we don't hear others isn't because they never existed, but because they no longer do. Or perhaps the signal is not gone, just hidden. Consider the possibility that a prior civilization reached a level of understanding that made communication unnecessary or unwise. Perhaps they learned the risks of exposure and encoded their legacy in forms we don't yet understand. Imagine knowledge stored not in data, but in structure, in protein folds, molecular logic, repeating ratios, embedded in natural formations that we chalk up to coincidence or dismiss as myths. Yes, myths. The oldest stories we carry often describe floods, lost lands, sky gods, and cataclysms. They span cultures and continents. Some see metaphor, others coincidence. But what if they are neither? What if they are filtered echoes of something real, distorted memories passed from species to species? A signal refracted through countless minds, and we modern humans may be the first to hold both the means and curiosity to decode it. It's possible then that the missing signal isn't missing at all. We are standing in it. We are part of it. We just haven't learned how to listen. Yet this reframing has consequences not just for science, but for philosophy. If intelligence is fleeting, if civilizations are short-lived flares in deep time, then what is our purpose, our legacy? What will we leave behind? And if someone comes after us millions of years from now, what will they find? Will they ask the same questions? Will they see us in the layers, or will we too become part of the silence? Perhaps somewhere in the stars, another civilization stares up at their night sky, asking the same thing. Where is everyone? Not realizing the answer lies below, in the quiet bones of the earth, in the layers of ash and stone, in the stories we tell and the ones we've forgotten. In the signal, we are still learning how to hear. What if civilization isn't the pinnacle of evolution, but a fleeting spark, brief, brilliant, and doomed to fade? From the moment humans began shaping fire, carving stone, and etching symbols into walls, we've imagined ourselves on a linear path, rising from chaos into order, from ignorance to enlightenment. Our cities sprawl like constellations across the planet. Our satellites orbit silently overhead. Our data pulses through glass fibers and through the air. It all feels inevitable, permanent. We know this instinctively. History is a litany of rise and fall: Sumer, Egypt, Maya, Rome. Civilizations have always come and gone, but we convince ourselves this time is different, that we are different, that globalism, technology, and science make us immune. But what if we are not? What if civilization is not a staircase but a wave? It rises and falls. And if that's true, then intelligence itself may be transient, not because it's rare, but because it is self-limiting. Think of it like fire. Fire spreads because it consumes. Civilization does the same. It devours resources, transforms landscapes, alters climates, and eventually reaches a boundary, a point where the system cannot absorb the change. Collapse becomes not a possibility, but an inevitability. Today, we stand on a precipice. Our technologies grant us vast power over the Earth and each other, but not necessarily power over ourselves. We wage war with tools of gods, sculpt the climate with our exhaust, and spin entire economies on the myth of infinite growth on a finite planet. And still, we gaze upward at the stars, wondering why they are silent. Perhaps they are not silent. Perhaps they are gone, burned out, collapsed, buried beneath their own ruins. And perhaps we are next. But this is also our opportunity, our fragile moment of choice. Even if civilization is a phase, phases can last. Fire can warm rather than consume. Growth can transform rather than destroy. This requires restraint, foresight, and a willingness to learn, not only from our ancestors but from those we never knew, those we imagine, those we suspect, those we might have been. The Sorian hypothesis is not just a mystery, it is a mirror. It asks whether intelligent life arose before, and if so, what happened to it. Then it turns the question on us. What will happen to us? We have a chance they may not have had. We know what fossil fuels do to the atmosphere. We understand feedback loops, extinction curves, and runaway systems. We have been warned by signals they may have left behind, chemical echoes, isotope ghosts, mythic firestorms. If civilization is a match, it is lit. How we burn it is up to us. So perhaps we are not merely a phase, perhaps we are the turning point, or perhaps we are simply the next in a long line of forgotten flames, soon to be buried, silenced, and become someone else's mystery. Imagine a child on a shore. The tide is out, the sand is wet, and they begin to build. Towers rise, walls are shaped. With proud, careful, precise hands, the child pats it smooth. But before long, the ocean returns. The waves do not care. The towers melt, the trenches fill, and all vanishes back into the sea as if it were never there. Civilization faces the same fate. Not only can our structures disappear, but the knowledge of them can vanish too. Records are lost, languages die, data formats become unreadable, libraries burn, histories are rewritten or simply forgotten. What then would remain of us? Perhaps the occasional anomaly, a layer in the sediment, a spike in carbon isotopes, a buried landfill. But these are shadows, not structures, hints, not legacies. Even these may be misinterpreted or dismissed entirely. So when we ask whether previous civilizations could have existed, we must stop imagining colosseums or pyramids. We must think more like archaeologists or geologists. We must accept that if anything remains, it will be deeply fragmented, and what we call absence may simply be erasure. Think of Earth as a recycling system. The crust is constantly reshaped. Mountains rise and are ground to gravel. Oceans advance and retreat. Forests become deserts. Continents break and reassemble. Anything built atop them, no matter how mighty, is vulnerable to being swallowed. Even today, we see it happening. Entire cities have disappeared in a century. Roads are overtaken by vines. Satellites crash into the sea. Climate change threatens coastal metropolises that once felt eternal. Stretch that to millions of years, and it's easy to imagine how a civilization could vanish entirely. But there's a deeper implication. If we could be so easily erased, then we must confront the possibility that others already were. Civilizations born before us lived their arc, built their towers, and then were swept away, their sandcastles undone by tides we never saw. Here is the most haunting truth. We may never know how many there were, 1, several, or 100. Across epochs, the geological record is spotty at best. The older the layer, the less survives. Even if a structure or artifact were perfectly preserved, it might lie miles beneath the surface, unreachable without knowing exactly where and why to look. In this way, the sandcastle principle becomes more than a metaphor. It becomes a warning, a reality check, a sobering lens through which to view our place on this planet. It asks, what are we building? And more importantly, will it last? Will anything we make survive? Not just war, weather and time, but forgetfulness. Will any trace remain after the tide returns? The truth is, most of what we build is designed for the now: efficiency, growth, speed, profit. We construct with plastic, not permanence. We store knowledge in cloud servers, not stone tablets. We bury waste, but not wisdom. Even our attempts at longevity, time capsules, monuments, digital backups, are hilariously fragile when measured against Earth's vast clock. If we wanted to be remembered, we would need to think not in years, but in eras. And yet, maybe we don't want to be remembered. Maybe part of us believes forgetting is mercy, that if we collapse, if we vanish, it is better. No one knows. But the sandcastle principle doesn't care about our intentions. It only describes what is, and what is that nothing built on shifting sand can last forever. So what's the takeaway? It's not despair, it's awareness. We must design, think, and live with impermanence in mind. Not to avoid collapse entirely, perhaps that is impossible, but to leave behind meaning rather than just material. To seed the future not only with buildings, but with questions, echoes, something that might endure, even if only as myth, mystery, or metaphor. Because somewhere down the line a new intelligence may rise, and like us they may search the sands and maybe, just maybe, they'll find a tower. Not a real one, not intact, but a glimmer, a pattern, a strange anomaly whispering that someone was here before them. That is what the sandcastle principle asks of us, not to resist the tide, but to leave a ripple behind. Beneath your feet as you walk your neighborhood, beneath forests, fields, and parking lots, lies a history you'll never see. Not ancient bones or buried treasure, but something more elusive: possibility. Consider how we explore the past. We dig where we expect to find things: known archaeological sites, old cities, human remains. But what if the most important evidence lies not beneath ancient Mesopotamia, but deep in the Australian outback, or at the bottom of sediment layers in forgotten swamps, or in core samples dismissed as unremarkable because they don't match known cultural markers? What if we have already uncovered fragments, strange alloys, inexplicable structures, fossilized patterns, and simply filed them away as anomalies, outliers, or natural oddities? The truth is, Earth's surface is constantly changing, but the vast majority has never been seriously examined, not even by geologists, let alone archaeologists. Only about 5% of the ocean floor has been mapped in detail. That's more than 70% of our planet, essentially unread. Even on land, many remote regions have never been excavated. And when they are, investigations are often driven by assumptions, looking for human artifacts, human bones, human stories. We may be searching for ourselves when we should be looking for something other, something we wouldn't immediately recognize. A prior civilization may not have used metal tools. Their structures might not have followed our architecture. Their technology might not have left wires, chips, or screens. Perhaps their computing was biochemical, their construction organic, their cities decentralized, grown rather than built. If we dig expecting pyramids, we will miss the petrified forest that was once a data center. And here it gets more intriguing. Geological core samples from various parts of the world sometimes show strange anomalies: unusual isotope ratios, microscopic spheres, layers rich in certain metals. Some have been attributed to asteroid impacts or volcanic activity, but others remain unexplained. In 2018, for example, a team at the University of Rochester examined a thin layer of sediment from the mid-Paleocene, roughly 56 million years ago. They found traces of platinum group elements, rare Earth concentrations, and a temperature spike consistent with massive industrial-scale carbon emissions. Officially, the explanation remains uncertain. Volcanism is the safe bet. But what if it wasn't? What if that layer is not the footprint of a natural disaster, but of a technological one? This leads to a haunting thought. If someone was here before us, we may already be standing on their ruins, not as we expect, not cities of marble or chrome, but layers in the soil, dust between fossils, altered strata that no one thought to question. Imagine a city, not New York or Tokyo, but some lost metropolis from a forgotten epoch, swallowed by the earth over tens of millions of years. Its buildings crushed into sediment, its streets replaced by stone, its infrastructure fossilized, not in shape, but in trace elements. Now above that, a forest grows, a road is paved. Children play unaware that beneath them lies not just earth, but memory. Memory written in the language of chemistry, pressure and decay. It is possible we have mistaken remnants of an earlier civilization for natural mineral formations or geological curiosities. We may have even drilled into the heart of some ancient reactor and simply chalked it up to unusual rock chemistry, and who could blame us? Our entire scientific method is built on precedent, on patterns. When something doesn't fit, truly doesn't fit, we often don't dig deeper. We label it anomalous and move on. But real science thrives on anomalies. It is the outliers that lead us forward, if we are willing to look again. Not all archives are buried in stone. Some are whispered from mouth to mouth, reshaped by firelight, bent by fear, softened by hope. Some memories survive not in ruins or fossils, but in myths. And myths, as we have long known, are dangerous things. They blur the line between history and imagination. But what if some myths are neither invention nor coincidence? What if they are echoes? Let's begin with a question that sounds almost childish in its simplicity. Why do so many ancient cultures from opposite ends of the earth tell strikingly similar stories? Floods, great floods, civilizations drowning beneath angry oceans, gods punishing hubris, knowledge lost beneath the waves, survivors clinging to mountaintops, the end of one world, the beginning of another. From the epic of Gilgamesh in Mesopotamia, to the tale of Manu in Hindu scriptures, to Plato's Atlantis, to the Hopi stories of past worlds washed away, to Noah's Ark, the pattern is astonishing, not just in content, but in tone. These myths don't speak of metaphorical cleansing. They speak of cataclysm, real destruction, a memory too vast, too painful to be stored anywhere else but in story. Some scholars argue these tales arose independently from real localized floods, rivers overflowing, tsunamis striking coasts, erosion. But that doesn't fully explain the uncanny resonance, nor the recurring symbols: sacred mountains, chosen survivors, forbidden knowledge. Carl Jung once called myths the collective dreams of mankind. But what if they're more than dreams? What if they're data compression? Imagine this: a civilization faces collapse. Its knowledge is vast, but its infrastructure crumbling. Satellites fall, power grids die, cloud servers go silent. It cannot preserve itself with technology, but it has something older, something hardwired: language, storytelling, archetypes. It embeds warnings and knowledge into tales, metaphor, gods and monsters, destined heroes and fallen empires. It tells children's stories designed to be remembered and passed down, reframed over generations until details fade, but the bones of truth remain. What would those myths look like to us today? They would look exactly like the stories we dismiss as fiction, folklore, or cultural coincidence. But what if Atlantis wasn't just a philosophical allegory from Plato's imagination? He claimed to have heard it from Solon, who heard it from Egyptian priests describing a powerful civilization destroyed in a single day and night of misfortune, swallowed by the sea. Scholars say Plato invented it, but others, including thinkers like Ignatius Donnelly and Graham Hancock, suggest there may have been kernels of forgotten history in the tale. What if the myth of the Tower of Babel, humanity reaching too far, trying to touch the heavens only to be scattered and confused, was a symbolic recollection of technological overreach, a civilization undone by its own ambition, What if the gods descending from the sky in flaming chariots were not divine at all but misremembered aircraft, drones or satellites seen and retold by those who came long after? And what of the seven suns in Mesoamerican myth, where previous worlds ended in fire, floods, wind and jaguars? Were these simply metaphors for natural cycles or shadows of ancient collapses? Even the Greek concept of cyclical ages, the Golden Age, silver, bronze, and finally iron, speaks of decline, loss, and forgetting, almost as if we've been through this before. As if Earth has witnessed not one but many rises and falls, each time a flame lit, each time it burned bright, each time it flickered and died, leaving behind only smoke and story. There is something elegant, almost poetic in the idea that the last will of a dying civilization wasn't a monument or satellite, but a myth, a story capable of surviving the death of languages, the erasure of cities, even the turning of continents. And perhaps we've misunderstood the purpose of myths all along. They are not meant to be believed literally. They are meant to resonate, to sneak truth into memory through rhythm, repetition, and awe, like a virus of meaning. So we must ask, if such messages exist, how would we recognize them? We'd look for thematic consistency across cultures. We'd seek symbolism that eerily maps onto scientific understanding they shouldn't have had. We'd search for mathematical structures embedded in stories, myths that align with astronomical data, or knowledge encoded in architecture and oral tradition. In a world obsessed with data, with evidence, with proof, we forget that memory doesn't always wear a lab coat. Sometimes memory wears feathers, paints its face, and tells stories to children. If we ignore it, if we fail to see what's hidden beneath the metaphors, we risk making the same mistakes again and again. Because myth is not just fantasy. It is what survives when everything else is gone. History doesn't always repeat, but it rhymes. And sometimes it whispers, not from the pages of textbooks, but from the ground beneath our feet, from the long silent record of extinction. We know the story well, or at least we think we do. A planet in peril, species disappearing, forests shrinking, oceans rising. We trace the arc of our modern world with grim familiarity. The graphs trend upward, warnings grow louder, the horizon narrows. But what if we are not the first to reach this cliff's edge? What if our acceleration, our heat, our hunger, our hum of machines is not unique in Earth's deep history? What if another hand once gripped the same lever and let it slip? The Sorian hypothesis asks whether an industrial civilization could have existed millions of years before us and disappeared without leaving behind the usual fingerprints of concrete, steel, or plastic. And here, we ask an even more haunting question. Are we following the same path they once walked? To explore this, we must hold up a mirror, not just to ourselves, but to the planet. Consider the Permian-Triassic extinction 252 million years ago, when over 90% of marine species and 70% of terrestrial species vanished in a geological blink. For decades, this great dying was blamed on massive volcanic eruptions in Siberia, releasing carbon dioxide and methane into the atmosphere. But recent analyses reveal a puzzling acceleration, as if something intensified the process beyond nature's usual pace. Carbon isotope records show a rapid, sustained spike, the same kind we are now creating through fossil fuel combustion. Is this coincidence? Perhaps. But maybe it's more chilling than that. Perhaps we are reactivating the same trigger they once pulled. The Anthropocene, our current epoch, is defined by unmistakable human fingerprints in geology. Plastic embedded in ocean sediments, radionuclides from nuclear tests, unnatural ratios of nitrogen and phosphorus in soils from agriculture, and a spike in atmospheric carbon. These are called techno-signatures, and they don't vanish quickly. A civilization like ours will leave traces for hundreds of thousands, maybe millions of years. That is where the sediment settles and forgets. Collapse doesn't always come as thunder. Sometimes it arrives as quiet erosion, the slow unraveling of complexity. And civilizations, no matter how advanced, are fragile when built on unstable foundations. This is the mirror of extinction, the reflection that doesn't flatter. Because when we stare into it, we don't see mystery, we see familiarity, we see ourselves. And that's the true terror. Our trajectory isn't unprecedented, it's archetypal. Civilization is not a permanent state, but a recurring phase, a chemical reaction that burns hot and bright, then stops. We can imagine ancient hands typing equations, drawing power from the deep earth, dreaming of stars. We can imagine their stories, their art, their children, and we can imagine them watching it all fall apart, too late to stop it, too certain to see it coming. This is not prophecy, it's pattern recognition. Because if we are not the first, we may not be the last. And what we leave behind or fail to leave may determine whether the next ones even know we existed. Perhaps that's the final irony. A species capable of changing the atmosphere, rearranging continents and launching machines into the void may be forgotten, not because of failure, but because of success, followed by silence. A brief flash in time, like lightning, brilliant, terrifying, and gone. So now we must ask, if we saw the signs in our own fossil record, massive extinctions, carbon spikes, buried artifacts, would we believe the civilization that caused it ever existed? And if we wouldn't believe in them, why would anyone believe in us? If we vanish, who comes next? That is the question that lingers, not in fear, but in curiosity, in deep time. Extinction is common, persistence is rare, and civilization may be just a brief flare, a spark on a dark timeline. But sparks can light fires. Let us imagine a future not of our making. Tens of millions of years from now, Earth spins on, older but not empty. The continents have shifted, mountains once young have crumbled. Our cities swallowed by jungles, oceans, and ice. Our satellites long since tumbled into decay, no more than dust dancing in the magnetosphere, and yet something stirs again. Not us, but something else. Evolution never rests, in forgotten valleys, deep oceans, or shattered fragments of ecosystems we once ruled. Life endures, and over unthinkable spans of time it adapts, it changes, it tries something new. Maybe it's born of birds, or rodents, or cephalopods. Maybe it stands upright, maybe it doesn't. It may never look to the stars, but it may look to the past. And when it does, what will it find? It will dig, it will study, it will probe the crust for clues as we do, and it will discover anomalies, thin dark lines rich in carbon, layers of microplastics, sudden disappearances of flora and fauna, unexplainable shifts in climate over a few thousand years. It will find a signal, but not a message. It may not know us by name. Our stories, our languages, our art may be gone or incomprehensible. But it will know that something came before, something vast, something capable of reshaping a planet and then leaving it in silence. And perhaps they will wonder, were we gods? Were we myths? Were we warnings hidden in their own myths? We may appear as sky beings or firemakers, dreamt up in origin tales to explain a strange stratum of the earth. Our machines, now oxidized fragments, may be seen as natural formations or divine relics. Our brief burst of heat, radiation, and complexity may resemble a cosmic fever the planet finally healed from. And maybe, just maybe, they will recognize a shadow of themselves in us. Because the drive to know, to build, to transform, that's not just human. That's intelligence. And intelligence, like water, finds its own path through time. But will they repeat our mistakes? Will they too mine too deep, burn too hot, accelerate too fast? Or will they do what we could not, learn from ghosts? This is the final arc of the Sorian hypothesis, not just that we might not be the first, but that we might not be the last. That the cycle of rise and fall may be less a tragedy and more a baton pass in the grand relay of sentience. And perhaps, unlike us, they will leave behind not just footprints, but wisdom. Perhaps they will uncover our story, coded in stone, preserved in DNA, etched into the crust of the world, and they will understand not just what we did, but why we fell. And maybe, just maybe, they will look at our ruins not as cautionary tales, but as cosmic inheritance. Because if we can imagine them, they can imagine us. And if we vanish without a whisper, without a legacy, then we are truly extinct. But if we vanish and still guide those who come next, then in some way we endure. The earth is not just a cradle, it is a crucible. And though the fire of our civilization may flicker out, the embers may still smolder beneath the surface, in the fossil record, in the memory of the soil itself, waiting to be found, waiting to remind, waiting for the next ones. Thank you for joining us on this extraordinary journey through the universe here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us, where we unravel the darkest mysteries of space.